Okay, so let's continue with our coding exercise series. So open the leetcode.com and go to the problems tab. And in the search bar, in the search question, so you can search question number 105. So there is a question: construct binary tree from pre-order and in-order traversal. So this is the medium category. Click on it. Okay, so let's read the question. So given two integer array, pre-order and in-order. So you have two array, or you can say list are given. So if you see the function definition, so there are two argument passed. One is pre-order, one is the in-order, and these are the list of integer, right? Where pre-order is the pre-order traversal of the binary tree, and in-order is the in-order traversal of the same tree. Construct and return the binary tree. So in this question, you don't have the tree given. We need to create a tree. We need to create a tree, but we have the pre-order and in order is given, because to create a tree we should know the what is the root child, we should know what is its left, we should know what is its right child. Only then we can create a tree, right? So in the tree there are basically three traversal method: pre-order, in-order, and post-order. So in this question two were given: pre-order and in-order, and they said by using these two, can you create a binary tree? So can you create a binary tree? Okay, so let's look. Let's go to the whiteboard. So we have pre-order is given. So if you see the mention like pre-order 39257. So just 1 second, just a second. You can ignore this figure. This is the out. You can ignore this figure which is on the left hand side, because that is basically the actual output which we want to create. Only the thing we have given is pre-order. Pre-order is 3920 15 17 is given, and in order is given 931527. So this question will be solved if we know what is pre-order and what is in order traversal. So pre-order means, so first the root will come. So what's the root will come? So we know. So first the root will come, then left will come, then right will come. So if you see, so let's suppose we know the output. Just for the timing, let's suppose we know the output. So 3 will come, then left will come 9, then right will come. So in the right, so 20, 15, 7 will come. So first root will come 20, then left will come 15, then 7. So 3, 9, 20, 57. So in order traversal means first root will come, then left will come, then right will come. Okay. What is the, so this is the pre-order traversal. What is in order traversal? In order traversal means first left will come, then root will come, then right will come. So first 9 will come, then 3 will come, then right will come. So in the right, first left will come 15, then 20, then 7. So this is the in order traversal, right? But by looking the in order and the post order, sorry, pre-order and the in order, we need to find like what is the root, and then we need to find what is its left child, what is its right child. So if you just look at the in order traversal 9, 3, 15, 27, we know it starts from the left. We know it's from the left, but we don't know, like it could be 9, 3, 15 should be on the left, 20 could be the root. It could be 9, 3, 15, 20 could be on the left. We don't know. So by looking at the in order, we can't find what is the root child. But by looking at the pre-order, we know the first root is the first element should be the root. So by looking at the pre-order, we know 3 is the root, right? So by looking at the pre-order, we know the root, but can we find the left and the right? So can we find the left and right from the pre-order? We know 3 is the root, and after that there is a left and right. But what are the left child? Is only the 9 is the left child, or 9 and 20 are the left child, or 9, 20, 15 are the left child? We don't know, right? So but by looking the two combination, we can tell, okay, what is the root. So root we can get from the pre-order, because we know root is the first element. So first element in the pre-order is root. So we know 3 is the root. Okay. Now we know in the in order, whatever the left of the root is left, and whatever the right of the root is right. So we know 3 is the root. So if we see 3 is here. So it means, let me take the pencil. So it means, so this 9 is left part, and this 1527 is the right part, because we know the root from here. If we know the root from here, then we are going to know, okay, these are the left child and this is the right child. So we know the root. So we know the root 3, and we know the what are the left child 9. We know what are the right child 1527. So this is the first part. So let's jump to the direct to the like solving the question, because this is the first thing. Okay, so first we need to know what is the root. So how we are going to calculate? Whatever the first element of the like pre-order, that will be the root. Okay, so pre-order of 0, pre-order of 0, that will be the root. Okay, but that will just give you the value, because pre-order of 0 will give you just 3. But we need to create a tree node. How you are going to create a tree node? By this class. So they have commented out, by this class you need to create a tree node, because first you need the root. First you need the root, because to create a tree you need the root, and then you can connect left, then you can connect right. Now we already know the root, so at least we can create our root node, right? So to create a root node, what you have to do? So what you have to do? Root is equal to so root is equal to pre-order of 0. No, so this is the root of value. So root is equal to tree node of pre-order of 0. So that is root is ready. So tree node, and it will take value. So value we are giving pre-order of 0, and left and right are none by default. So till now we constructed 3. Now we should know, we want to know, because to create the whole tree we should know its left, we should know its right. Till now we only know the root. So half part is done. Okay, to know the left and right child, we should take the advantage of the in-order traversal, right? So first we need to find the index. So index of the 3, what is the index of the 3? Because there are 5 elements, so 0, 1, 2, 3, 4. So index of the 3 is 1. So whatever the left hand side of the here, that are the left elements, and whatever the right hand side of the 3, that are the right elements. So now here we have 9, here we have 15, 27, but can we attach like this only? 9, 15, 27? No, we know we need the output like this. We need the output like this. We need 3, we have 3. But even here, here like at the bottom of 3, we need this output 9, 15, like 15, 27. Okay, 9 we have single element, we can attach. But what about 15, 27? We can't attach in an array. We should not attach in an array. We should create a different tree. We should create a different tree. So basically we can treat it as a sub problem. So if we have only 3 elements, 15, 27, all right, so instead of 5 elements, if we have 3 elements, because we know now in order is 15, 27. Now in order is 15, 27, and we will come to the pre-order, what will be the pre-order. But we know the in order is 15, 27, and we know in order is 9. In order is 9 to create the tree. All right, so can we construct the tree? Right, and what if we construct the tree? We have to just connect it with the right of 3 and left of 3. Right, so what we have to do? So first we need to find the index, because until we don't know the index, we don't know what are the left element, we don't know what are the right element, right? So we need to find the index. So let's find the index. So how to find the index? Pre-order dot index, and sorry, in order dot index pre-order of 0. Or you can take some you can like get the value maybe like this. Value is equal to pre-order of 0, and then you can remove that, and you can put value, and here you can also put the value. So you can like in the 3 steps, or maybe you can do in a 2 step. That is perfectly fine. It's not going to impact your like performance. So value is pre-order of 0. So we got the value 3. Okay, let's create the root child. We have created the root child tree node of node. So now we know we should know the left child. So we have the left child. Sorry, we should have the index. So we for index we will get calculate of the in order. So in order dot index and then value. Okay. So now we have like index. Okay, let me rub this. Let me rub this. Okay, let me rub this. Okay. Now we have the index. Okay, what next? We have the root. So we need to attach left child. We need to attach right child. We need to attach left, and we need to attach it. But in the left, we need to attach one tree. In the right, we need to attach one tree. So basically, whatever the left, we need to create a tree node. from this. So we need to create a tree. We need to create a tree. So build. So we will call the same function again. We will call the same function because now we treat it as a sub problem because we know there are one element. We know there are three elements. So earlier in our question, five elements are given. Five elements are given. So we constructed. All right. So now we will treat as a sub problem. So now we will see, okay, we have three elements are given or one element is given. Can we create its root? Because if we create its root, it will come and it will attach to its left. It will come, it will attach to. So basically we will call the same function again. So we will call the same function again. Okay. So how to call this function? Self dot, self dot. Okay. But this function take two arguments, pre-order and the in order. So let's write pre-order, let's write in order, let's write pre-order, let's write in order, which is perfectly fine. But we can't pass the same element again and again because otherwise it's never ending loop. So now we know because if we pass the same element pre-order, the in order, then it will be again same. We are again going to attach the three with the left and three with the right. So we don't need. So we know now the we know now our right will be this and left will be this. So in order will be this and in order will be this. So we have the index. Okay, so let's get at least that. So get so we need to use the slicing operator. So we know the index. So what is index? Index is one. Index is one. So we need 2, 3, 4. So how we are going to get? So index plus one and till last. So we will get the in order. Okay, now in this case, how we can get the index? So till okay, sorry. So how we can get the index? Till index plus one, because if we take index, then it will be like uh okay so till index. So we will get the till index. So we will get till index means like zero and index is one. So we will get only this element because index is already covered. So in the in order, we will get sorry, we will get this three, this nine, and we will get 1527. Okay. Now, but what about the pre-order? What about the pre-order? So we need to take the some slicing. Okay. So okay, let me take the cursor. So now we have the index one. Index one. Index one tell us two things. One thing is it is telling what are the left child and what are the right child. Along with that, it is telling how many are on the left hand side and how many are on the right hand side because it is index one. So it is common on the left hand side, there is only one element because it is index one. If it is index two, it is common on the left hand side, there are two elements. If it is index three, it is common on the left hand side, there are three elements. All right. So now we know on the left hand side, there are only one element. We know on the left hand side, there are only one element. So what will be the pre-order? Pre-order one is already done. One is already done. So we have to start from next element. So we have to start from next element. Okay. We have to start from next element. Okay. But how many element we need to take on the for because root already done. All right. So now we need to take the left. So now we need to take the left. So left will start from one. But how many elements? How many element means this index? This index. How many element means this index? Only one element. So index plus one. Because if we put one, then one column one, it is not going to give me anything. So I have to take till two because the last element is not considered in slicing. So only 9 will come because this one is going to tell us what elements are on the left hand side, what elements are on the right hand side. Along with that, this one is telling how many elements on the left hand side because if the index is one, it is common. There is only one element on the left hand side and there are three elements. Let's suppose if the index is two. If the index is 2, it means these are the left-hand side. And how many elements? Two elements, 0, 1. Right? So we know there are how many elements. So now we know pre-order. Okay. So in this case, we know rest all the elements. So we have the index. So we know rest all the elements on the right-hand side. Rest all the elements on the right hand side. So what is this index? Index is 1. So we have to do index plus 1 and the rest of the element. And we need to return the root. Okay. But we are using the recursion. So if we are using the recursion, we have to use the base condition as well. So what is the base condition? If not pre-order or not in order, return none. Because there will be a time when nothing will be in the pre-order and nothing will be the in order. Let's try to run it. So let's see if there is any error. So unindent does not match any indentation. What indentation? Okay, just a second. I need some indentation. Let's run it. Hmm. Okay, we took index, so let's run it. Okay, sample KC has been accepted. Let's try to submit it. So our solution has been accepted and all the test KC has been passed. Right. So this is a very simple question. This is a very simple question because you have pre-order giver and you have in-order giver. The only thing is you should know what is pre-order and what is in-order, and you need to return a tree. So to return a tree, first you should know the root. So how you are going to know the root? So we know in the pre-order the first element is the root. Okay, so we know the root. So we know the root. So let's create a root chart. So let's create a root chart. Now we need to create the left and the right. So we are creating the left and the right. Okay, now we know in the on the left only one element will be there or whatever the element, and on the right this. But we can't attach this whole array. We have to build a tree again. So we will consider it as a sub problem. So now in order is 1527 and pre-order is 2050 All right. So in order is 9 and pre-order is also 9. All right. So that's it. That's the end of the video. And at the end you can return the root. There will be a similar kind of question. I think they have suggested something. No, this is something different. So there are similar kind of question. Maybe they have given post order and you need to like, can you create a tree? So there are same set of questions. He is generally asked in the interview. So that's it. That's the end of the video. Thank you. You can also try this question.